If we move in now on the spiral, to go to a closer view of it, we have made, so to speak, one full revolution from alpha, which is infinite distance away there, and we've gone round completely once. We've turned around through 360 degrees, and we arrive at the value of 1 because we have made one total revolution. And at that point, we can say that the string length, so to speak, is 1. We have completed the period of what you might call pregnancy, because before 1 there is nothing. There is no wholeness before we arrive at the 1. And after that, then we enter the world of the physical world. Before that is still transcendental, and from this point 1 onwards, there has become an individuality. Before an individuality, there is only energy. And with a string length 1, after one full revolution, we have moved into a position of a half, into a third, into a quarter, into a fifth and sixth. Exactly the same in reflection of the hyperbola which went up in the other direction. So here we would have the distance 1, there would be 2, so the elevation of this would be a curve which goes up in the opposite, in the other dimension. And into this can also be interpreted musically, because the string length being 1 would have a certain tension, and then as we reduced the length of it, the tension would give rise to all the various notes that they are aware of, and it would be just wherever the string length is, gives you whatever the note is, so to speak. And then you find some interesting relationships that in the major notes on the scale, they are always divided by multiples of 15, 30 degrees, 60 degrees between F and G, and so on. And the other half notes are multiples of 3 or 9. So one begins to get certain insights into the patterns of energy by looking it through the spiral form. This is also another one which interprets in terms of color, that you start with the base tone where you've got the rather darker color. As you move around, then the color becomes a higher frequency, so that it's a lighter color, but still going through the full spectrum, so that it begins to teach you how eventually all colors return to the source from which they came, which was white. And also an idea of the higher vibrations of colors that, for instance, clairvoyants and other sensitives are aware of, which are really merely harmonics of the lower ones. This spiral that we saw before is also the spiral by which you can use to divide any angle into any equal parts, any number of equal parts. Now, if you've looked at a pineapple, you've seen that it has spirals on it, maybe 13 going one way and 34 going the other way, or on a pine cone, there's 5 going one way and there's 8 going the other way. So how does nature make these beautiful divisions? Because 13, to divide 360 degrees by 13 is a bit difficult, or by 24, or by 33. But if you take this hyperbolic spiral and you want to divide an angle, let's say this angle AB, then you take your compass, you make a mark at the top and the bottom where you want to incorporating the angle, and then with that radius you multiply that radius 5 times if you want to divide that angle by 5. And once you've multiplied the radius 5 times, then you have this length here, the green one, which then has the value of 1. And you draw an arc from the center to where it cuts the hyperbolic spiral, and you draw a line to the center. Then you reduce the radius to a half, and you do the same, and then you take it to a third, and the same, and a quarter, and do the same, and finally to a fifth, and you divided that angle into 5. And here again is the hyperbola when you connect all those lines together. So it's a kind of mathematics which seems to be very integrated. If you take a section through the hyperbolic cone, then you can get fish shape. This is the hyperbolic cone, part of it there and part of it here. And taking an angled section through it, the flat plane that you can see would have this form. and there's a bit of the tail of the fish too. If you cut it in another section, slightly flatter, then the egg can be obtained from that. So with this system, it's possible to create any egg precisely and mathematically to determine it. You can design your own egg, so to speak, the one which is most suited to whatever purpose you require. And according to Walter, maybe it was even in the shape of the egg itself that the flight characteristics of the different birds were, because one kern of curvature produced one form, a different curvature on the egg produced a different kind of bird. I don't know if anyone has really made an accurate study of the precise dimensions, but they're all different sizes of egg, and all the birds have different flight characteristics. And so in using this process, I've actually been able to make some eggs. These ones hold about, I think it holds about 5 gallons or something. It was made as a water device. And this shows you a little bit more how you can make sections through these cones. These are various sections taken through the cone, and from these you get a number of different egg shapes. This one, for instance, would be taken. It's difficult to do this without relation to the cone. I'll try and put that back here. No, I think I have to take it out. It depends how pointed the egg is, depends on how steeply you make the cut through the cone. And it doesn't matter where you make the cut on the thing, you can always define it from a mathematical point of view. These are all different egg shapes. And these are the data which correspond to it, so that it does show you that they can be very precisely defined. It's a different one. I'm afraid it went slightly